I'm going to talk about my clustering assignment which I have submitted. So in this assignment we were supposed to do a few algorithms from scratch, as you can see. So we have k-means, hierarchical, and then we have Gaussian mixture models, and then we have DB scan clustering and a few other ones which we are supposed to execute, and we have also the hints. And then so this is my GitHub repo that I have. So as you can see, these are all the IPynb files that I have along with the required CSV files, unless it's coming from some source. Otherwise the CSV will be here, so we'll be able to run it. And then as you can see, we have all of these. So clustering, basically uh, it's like grouping of data points, we can say. So we have different types of algorithms for that. As you can see, these are all the clustering algorithms we have executed, and a few other ones where we're doing image clustering, audio extraction and clustering, and also document clustering. So yeah, so let's begin with the first one. So I'm going to divide them into two parts since I don't want the video to be too long. So starting with the k-means clustering, as you can see, we have imported Seaborn. So this is for the visualizations, and then we have NumPy. So as you can see, k-means algorithm, it searches for the predetermined number of clusters within an unlabeled multidimensional data set. So, and also the cluster center is the arithmetic mean of all the points belonging to the cluster. So as you can see, if these are all if this is considered as a one cluster, then the arithmetic mean will be at the center of the cluster. And also each point is closer to its own cluster center than to other cluster centers. So basically we have a center, and then we calculate the distance of all the other points from that center. And like if this point is close to this center, then that means this point belongs to this cluster. And since this point is closer to this center, so this automatically groups into this cluster. So it's as simple as that. So first of all, we have the sklearn dataset. So here we're importing make blobs, and then we just took a random sample over here. So 300 centers 4. So here centers 4 is nothing but we just like predetermine the number of clusters, and then we just have a scatter plot over here, and then after that we are importing the k-means cluster over here. And then as you can see here, we're calculating the centers. So this black point is nothing but the center, and then we're going to find out the distance of every point from all of the centers and check which center it's the closest to. So as you can see, it assigns the points to the clusters very similarly to how we assign them by eye. So like this belongs to this, obviously. So even to a naked eye we'll be able to do that. So it is kind of simple to understand. And then here we have two other things called E-step and M-step. E-step is nothing but it assigns points to the nearest cluster center, and M-step is nothing but it sets the cluster centers to the mean of their assigned points. So we're just finding out the clusters over here based on the distances. And yeah, this is how the clusters are grouped. So if you take this point, maybe it was closer to this cluster center rather than this cluster center. That is how it got grouped into this one. And yeah. Here we have another cluster. So as you can see, if we have to predefine the number of clusters. Since we have given 6, it's going to form like 6 different clusters, as you can see. So yeah. And then here it says k-means is limited to linear cluster boundaries. So it is a two-dimensional one, I would say. So because these are together, that doesn't make them one cluster. These are together, that doesn't make them one cluster. They're going to be divided in a two-dimensional way only. So as you can see, this is another kind of different thing where we are using spectral clustering. So it uses a graph of the nearest neighbors to compute high dimensional. So basically like increases the dimensions. So you can group, if you wanted those to be grouped like this, then you can use spectral clustering. And then we're just gonna do a few examples where we're doing k-means on digits. So we're just taking the nearest like the cluster center, and then we're reshaping it, and then we're just getting the accuracy. Over here we're just plotting the confusion matrix, and this is the TSNE. uh, it's a non-linear embedding algorithm that is adept at preserving points with clusters. So that is that, and then we have k-means for cluster color compression. So displaying the shape and then resizing it, and then we're plotting the pixels. So basically we're just taking all of the colors and then making a scatter plot after that, and then we're grouping them, or like reducing the colors. So we reduce the number of colors using a few groups of colors, as you can see. So all of these gradients are gone. So basically compresses the image. That is all about k-means clustering.